What I'm going to go and have you take a look at right now, there are 3 exercises. There's 5A, B, and C, okay? And what I'm going to go and take you through is, first of all, the first 2 have the amplitudes extracted for you, and you just go and do the analysis on it. The third one, you need to extract the amplitudes. There's a mixture. The first one, the information is not normalized for you, and you need to go and do a background normalization of it. The second one, I think that it is normalized for you. And the third one, you just have to extract your own amplitudes, but they're sort of not normalized. And I'm trying to build up things via repetition. I mean, I think that you saw in the earlier ones, there's a lot of button pushing and why am I doing this, and I can't see the forest for the trees here. That here I'm trying to get you to go through multiple iterations so you start focusing on the process and what we're really trying to do. Maybe the first one you'll be obsessed with the trees, but hopefully by the latter ones you'll be able to start being able to take a look at the forest. And then with the final exercise tomorrow, be able to really take a look at the forest as you try to evaluate the different prospects, okay? And before we get into that, I think I want to go and show you a bit about the amplitude analysis spreadsheet. The amplitude analysis spreadsheet, let me show you where that is on the workflow. We will be going in the first 2 exercises, the amplitudes are extracted for you, so you have these amplitudes. And we're going to be here in the amplitude analysis spreadsheet utilizing these amplitudes. And what we're going to try to get are these net sand and these probability of pay maps, okay? That's the objective, okay? We want to have net feet of sand and want to know where we have high probabilities of pay or low risk, okay? So that's the objective here, okay? And then for the C, with the third example, you'll have to do the amplitude extractions, okay? And then use those amplitude extractions to do this, okay? And so we'll sort of build you up a little bit to that, okay? And as part of this, I want to go and give you a tour through the amplitude analysis spreadsheet and talk a little bit about the logic in it. Sometimes Excel's a mystery to me. Okay, we have exercise 5A, 5B, 5C. Let me go into exercise A. There are 2 major spreadsheets here, or 1 major and 1 minor spreadsheet. And the minor spreadsheet is just a little tuning calculator, and Dave did that little, mental calculation. If you get the dominant frequency and the velocity, it'll tell you the tuning thickness, and to answer one of the questions at one time, you'll need to sort of use this little calculator. And so I want you to sort of know about it, and so that you can sort of plug your own numbers in from time to time as you need to. It's only going to be utilized in this exercise. Let me go and I'm going to open up.
How would you know what your dominant frequency is?
We'd ask you. Well, you can go and take your data. If you had one of these spectral signal to noise plots, you can go and understand it. Also, many times, if you just go and take an FFT of sort of an average trace, you can also get a particular idea on that. Do you have some things you wanted to add? I think you were acting as a straight man for yourself there for a second. advertising use of your services. But actually, Mark would be a very good person to talk to about what the bandwidth is. What?
Can't you just do that post-stack copy?
You can also do that post-stack copy.
Yeah.
Yeah, I think, Mike, also, you know, that simple calculation can be, I don't know, probably about 20 or 30% off, depending on what type of wavelength you're working with.
Yeah.
And, I think that calculation is based if it's a cosine wave.
Yeah, I think so. And you can actually see, I mean, we don't cover anything up here, the formulas are in here, so. And also, I mean, I think that you want to go, there's always a thing is it the middle frequency, or is it sort of the high-end frequency that you end up putting in to sort of define what your particular tuning is? Because if you're fairly flat out to 80 hertz, the center is 40, you use 80 or 40, you still have very good signal to noise ratio at 80. I would tend to think that, I tend to put in the 80 if you have, you know, sort of the last frequency where you have good signal to noise ratio on your data. This particular spreadsheet really is set up as a workflow. You just sort of go through it. That you need to make sure all of the yellow cells to the left are filled out before you hit the box down below it. And then it tells you here what plots to expect. And also from time to time, certain numbers will be output after you've gone and clicked on that box. That's sort of the simple sort of tour through it. There are different tabs down here. Many of these things have been set up for you. One thing have been set up are what the expected amplitude responses are. It's already been entered the results of the previous exercise. But that's where those results get entered in. You can also go in and we do put in where the wells are. And if you want to see where they are and what values are at the wells, you have to hit load wells here, or there's an equivalent button on the front page. We also go in and make sure we have the inline cross-line to XY coordinate transformation. So you can actually even hit this convert and put them in here, and if you only know them in X and Y, you can actually convert them back here. If you go into the workflow, the load wells button is also here, so you need to go and press that and make sure those values are put in. But it all starts with going and saying read the data, and these end up being files that are output from the amplitude extractor. We have the amplitude area, we have the width as defined. We do have a depth grid, so we can check to fit the structure, and we also have a particular background map. Right now, MATLAB is out there reading the particular grids in. It'll take a little while. When it's done reading them in, it'll display graphs of the width, background, depth, amplitude, and area as have been read in.
So basically, interpret all this in size works and export them in XYZ?
Yeah, well, in fact, if you go, and I'll show you when we get into the QI workbench, it's pretty much like running post-stack PAL. Use Tullet and pick your volume. You say extract it. You'll have events put back into Landmark that you can view, but they also will be output in formats that can actually be directly brought into this software at the same time for you. So you're not going to have to worry about that particular export, okay? But I'll show you that when we get into 5C and start showing you a little bit about the workbench and how that's done. You see here that it says scaffold area, so that's the secant area. This is scaffold amplitude, that's the secant amplitude. This is the background map. You see there was significant acquisition striping here, but it is actually synthetically generated. It's pretty obvious. You also have the depth map to be able to check the structure. We also have the width map, so you can see where we're thick and can count on the amplitudes being above tuning. Then we can go now and start going down through the workflow. At this point, you want to load the wells. you better background map normalize because of that structure, and you'll see that now the normalized amplitude this is after the normalization versus before the normalization, and you can obviously see the striping coming through here, okay? And it's been eliminated afterwards. We then go and ask you to determine the normalization or pick this sort of, what are the millivolts associated with. In this case, we pointed you at the gas leg because we do know that we have a well in here that says this is gas. And one thing to note is we blank out wherever things are at tuning or below. So we don't allow you to pick where things are at or below tuning. Okay, since we have that width. And so now you can be a little bit more cavalier about where you pick since it is sort of blanked out. You click around, double click on the last point, and it'll show you what these sort of raw units are. And you'll want to go in and yours will say, okay, you effectively copy this value down into here, and you want to normalize that to the expected amplitude ratio. And then you'll just say normalize the amplitudes, and it will go and show you the amplitudes in terms of normalized A over B values that go between 0 and 6. It shows you the structural contours in this place, and will also show you the well locations. If you wanted to go then and know what the amplitude looked like along a cross section, just go and pick, the points through which you want to see how the amplitudes change, and it will show you the amplitude profile there, which is kind of a handy thing to do. You can go there and say, okay, what's the average amplitude in this target leg here that are above tuning thickness with this intermediate area, and you see that the mean amplitude is 2.7 plus or minus 0.7. You can then go and do this, calculate the net sand. You need to give it that net to gross, the sand velocity, and the expected amplitude for oil, which you can see is fairly close to the mean amplitude. Then you can calculate the net sand. This is in meters, and you can see at the well location it was 22 meters, which could be should be compared to the well value. And we'll talk a little bit more about that as we go through the exercises. You can then integrate to find your volumes, and say if we're interested in stuff in this leg, I'll go and click here and say I want to integrate volumes around there. It tells you the net sands in millions of cubic meters, hydrocarbon in place in terms of millions of barrels, and also, let's see right here, this is also, let's see, well, this is net sand, and this is hydrocarbon in place in terms of millions of cubic meters. It also tells you in acres feet for those of you from the Gulf of Mexico. And also this is BCF at reservoir conditions. You tell it the expansion factor, recovery factor, oil expansion factor, oil recovery factor. It'll tell you how much either in BCF or millions of barrels in terms of recoverable. This is not meant to be a replacement for other methods, but if you want to do quick and dirty stuff, you can find out whether it's big or little fairly quickly. Also, those probability maps that I showed, well, you press this button and you get the probability maps, okay, coming out. And you can also export these again in terms of line trace value, or you can convert these into XY maps oriented correctly, and also output them in terms of XY value maps, which is handy, especially if you're going into something like OCAD or Petrel for reservoir modeling. Okay. I sort of took you through the overall, all of the boxes that you're going to need to go through, but there are a lot of little lessons that you're going to learn along the way, and some of the subtleties of normalizing these amplitudes and picking things. And so, sort of follow the bouncing ball as you go through here. And I'll go and sort of tell you a bit more about the QI workbench and extracting amplitudes when I see most of you are about ready, or some of you are about ready to get to exercise 5C. And also, once I see that you're sort of, most people tend to be done with A and B, I'll sort of go and have a few lessons you should have learned from your work on it. Okay? And overall, we're looking at being done with lunch at 1 o'clock and being done with 3 exercises by then. Lunch should be available starting at about 12:30 as usual in the room next door. Now's probably a good time also to take your sort of tea time, morning break, and delve into the exercises as needed. If we need a little bit of time after 1 o'clock, we can adjust for that too in terms of getting you guys through the exercises here. Okay? Back to the QI viewer and what you'll need to do with respect to that. In fact, we've simplified your life a little bit, and I'll sort of bring you up to speed on that. But the one thing that I did want to discuss a little bit has to do with what happens when you drill a well as we move from an exploration to an appraisal situation. And I went through here and did the initial analysis, and I was told by the geologist that where I ended up picking my normalization should have been about 70% average net to gross. I said, okay, fine. I went and calculated things, and I found that the Sty Barrel 1 location, it said there were about 14 meters of sand. But obviously now that we're in an appraisal situation, we know that there's actually 18 meters, okay? And you have to understand that this was a particular guess on the part of the geologist of what it probably would be, and that, we just don't know, and that's really what happens in an exploration setting. We don't know as much, okay? But now that we have this information, we know this is low. So what I want to do is say, well, let's go and say that it really should be, let's say, 90% possibly. And when we do that, you end up finding that you end up getting the right amount of net sand at this point. So we have used the well information now to go in and to calibrate the amount of net sand that we have. And if you had 2 or 3 wells, you probably want to choose a value that on average gave you the right value at the different wells that you have, okay? And so there is, and we'll do this another time in the course, we'll have a little bit of tune-up given some well information to what we have, okay? So it's a good thing to keep in mind as you go through this analysis, okay? That's why I sort of had that little detour in this, okay? Did anyone else have any particular questions or things that you were confused by going through the first 2 parts of this exercise? Or okay, I've been trying to go around. Now let me go and show you a little bit about the viewer, workbench, and the amplitude extraction. This is the Sty Barrel data that you've been looking at. What I'm going to ask you to do here, though, is, sorry, I'm going to close all this stuff. I'm just getting rid of all those windows. Now if you go in, and I think that all of you will have, I think most of you have it over here on the left, but you'll see this particular icon, and you'll want to go and just sort of double click on it. Okay, this ends up being a project selector. I'll shut this up. Okay, that you go down and first of all you pick a server. You all will only have one choice here. Pick the one choice. This normally is a location like, is your data in Houston or is it in Perth? Make sure, and I'll go and accentuate this, make sure you always click remote because you want to go and get the data from the server, not from your local Windows side. And also, I think I tell you which project, and it should be the Stybarrel QI course, and this is exercise 5C. So this is sort of location, this is what project you have, and this would be equivalent to a landmark session, okay? Then once you go and have this, you just go and hit OK, and it will go and restore that session for you, which happens to have an open viewer in it. It's bringing the data down to view, and now we have the open viewer. And there are a couple of things to notice here. Here is, first of all, your project, and it shows all the different data sets that you do have out there, all the horizons you have. In fact, if you double click on one of these horizons, it should bring it up so that you can view the particular data in that horizon. You can see the different sort of seismic SU and other files out there, as well as any other scripts and the like. And I'll sort of show you in a second a way that you can end up utilizing this. But in general, I'm going to go right now and click over to one of the viewers. And one thing to notice about this particular sort of desktop here is the thing over on the left. It sort of shows you each different application and which particular sort of sub-sessions you have for that. So this is a viewer. It's set up to view things before you do the amplitude extraction and after. Currently, the view before is open, but the view after is sort of there and closed, and I would suggest not opening the thing after until you actually do the amplitude extraction. It also has one amplitude extraction on it. This could be multiple ones. Like if you had 4 or 5 different horizons, you could have 4 or 5 different amplitude extractions. And if you go and click on this, it will actually open up a little dialog that goes and shows the the parameters for this particular amplitude extraction. The first is what data sets you want to go and extract things off of. And if I go and hit browse, I'm sorry, there's a little bit of a screen issue here. It'll go and give you a list of files that you can go and choose from. Once you go and open it, it'll give you the range of data in there, and you can decide to just go and extract on a subset. You also can go and click on landmark, in which case it'll go up and bring up a list of your landmark projects and then what seismic data sets. And you can choose the landmark data set and what subcube you'd like to extract your amplitudes on. In case you want to rotate your data or run sum your data, if it isn't run sum, it'll go and do that on the fly, and we'll export that data set back to landmark if you would like. Okay, so if you want to run some data, this is a quick and easy way, or rotate it. It's sort of operating like post-stack POW. You need to go and define either the top and base horizon, that P1, P2 pick, in which case you can go and then just sort of browse for the list of horizons that are there. Or you can actually drag and drop from that list that I showed before in the project. Or you can go into point mode, in which case you tell it the middle point, and then it will go and try to find the sides. You can also bring these in either from ASCII files, from landmark, or from some of these ones we have loaded into sort of a special format for this particular viewing. You can then choose whether or not you just get stuff so we can view it locally, or you can go and put the output back into landmark so you can view it there. This is just what you want to sort of call this data set and the sort of local ASCII events. And then you want to go over to job status, is where you actually say run it. And just like in post-stack POW is where you say run the job. You can check the status periodically or cancel the job right here. And when it's done, it'll just say, sort of I'm done running. Everything is gone and is set up for you. You don't need to go and change any of the parameters. For those of you interested, I can come around and talk to you a bit about what these parameters are in terms of how you should set them. There is some help here too that you can go and ask for. It's probably not fully though populated yet, okay? And then once you've gone and sort of done that amplitude extraction, which I have done here, it should only take probably 3 or 4 minutes to do the amplitude extraction to give you an idea. You can go and then double click on this to go and open up a viewing session after the amplitude extraction. There are multiple layers. It's brought all the data over here, okay, already. And right now I'm just going to go and though close this and go back to stuff before and sort of talk a little bit about the sort of the process here. Let me go and quit out of here. And this goes and shows a structure map. You can see your high over here and low down here. There's an arbitrary traverse that's actually chosen here. You see 2 picks, one near the top and the other near the base. You see a sparse spike inversion in the background, and you see another higher frequency sparse spike inversion that came from some more recent data shown as wiggles. You can go, and there are multiple layers here, and some of the RFC data is not turned on, and that's why it's grayed out. You only see the sparse spike inversion on the bottom and the sort of the new data in run sum phase shown as the wiggles. So if you want to go and say, I don't want to see that run sum data anymore, you can either right button mouse click and say hide that layer, or just hit the little red button up here. Now all we see is the sparse spike inversion. Normally at this point I take a look at the events and say, look, the event is here. I want to go and pick and have it be sitting over here. And I know I sort of have to add a DC shift, and one thing I can do is add a DC shift onto this event and then tell it to sort of search around this much. And if you want to know how much that is, it does tell you what the time is. And so I can see I'm at 2284. I want to shift it up to 2280, so it's about 4 mils up. And I want to go and sort of look 4 mils on either side of it, okay? And I'll do the same thing on the one that below it. I actually want to shift that down 4 mils and probably look 4 mils on either side of it for where this is. And it will actually snap it to that maximum and then look for the minimum in between. But let's say I want to take a look at the old RFC data. Well, I can right button mouse click and say show it. And you now can see the old RFC data overlaid on the overlaid on the sparse spike inversion results. Okay, and then also when you go and highlight one of these events, you can see that it actually sort of has turned to yellow. And I'll go and you sort of see I'm switching from the top to the base. One thing that if you did actually want to go and modify these picks, when you have it selected, if you actually move along it, it actually will go and you can sort of re-pick and sort of edit those points. We don't ask you to do that here. But another thing you may want is to take a look at another arbitrary cross-section. If you go back to the map and just do a series of clicks to define the arbitrary cross-section that you would like. And when you're done, you just right button mouse click once to terminate it, a second time, and you just want to say broadcast the traverse. You also could delete the traverse. The one you wanted to pick is broadcast the traverse.
And it should be going out.
Yeah. And it's gone and gotten all the data through this other traverse. And in fact, as I move along this arbitrary traverse, you can see the cursor on the map is tracking where I am, okay? And so there is a standard sort of map tracking in this as you move around. And then after you do the extraction, one thing that you want to check for is that you really have gone and have captured the right edge picks. And you can see here where these edge picks ended up coming in. And in fact, I don't like that data on top of it. I just want to see that sparse spike inversion. And you can see it's gone in here and has locked in here, but you sort of see this jitter where it's going up and down, where I talked about those little side lobes over here on the board. It's actually clicking and going from here to here, depending upon small changes sort of in the balance of sort of the noise or even a little bit in the stratigraphy. As I discussed before, that shouldn't really have a large effect. You see it's very good at going and locking on to where the biggest negative is. And that's a type thing that you should be looking at here. And then though, since you have extracted the amplitudes, here is, for instance, the area coming off of there, and here is the amplitude. And if you wanted to, you could go here and pick the arbitrary traverse on the amplitude map and just go ahead and broadcast that back to here in order to be able to see how things look along any particular arbitrary traverse, okay? And so I just wanted to go and demonstrate to you right now sort of some of the basics of how you move around here. The one thing that you won't have to do is I'll go, and I do talk to you, it did talk about going and having to copy some events from one folder to another. You don't have to do that. Those events are already been copied for you. So that after you're done extracting, you can immediately open up the amplitude analysis spreadsheet and click on the read data, and it will already be in the proper location. And you don't have to go through any of the particular copy and change names part of this particular exercise. Okay?